At the embassy, yeah. So 1, 2, 3, 4, 5, 6, 7. So just him. Did Yahya give you his question he wanted you to ask me? No? Nobody got the question after him he wants to ask? That's fine, that's him. So we will have a look at some maths tutorial questions first, yeah? So what are we looking at first then?
I think it's the implicit rule lesson.
Yeah.
Question 3, part G.
Okie dokie. We'll have a look at that one first. So if you want to open it up on your phone, we're looking at implicit. I don't know if you want to open it on your phone.
Do not open in here.
I'll open it in here, but if you want to open on your phone, go ahead.
Oh.
Workbook. Maths Part 2, Engineering, 3G.
Yes.
Okay. And what's difficult about it? Or you think the answer's wrong?
It could be, because I tried every way.
You tried the right way?
Yes.
Oh, and you got the wrong answer.
Yes.
So maybe the answer is wrong. Maybe.
Because I tried another one. I tried part M, and it was also had the same problem. And I tried all ways like I could think of with it. I even watched the lesson again.
What answer did you get for 3G the first time you did it?
I think 9 over 8.
And what's the answer at the back?
I can't remember. But I remember M's. Like I got 24 over 17, and M was 3 over 4 in the
okay, let's investigate. Maybe my answer's wrong. So you tried 3G. Right. Now, it's minus 2x squared. Why is it so slow today? Must have did an update last night. Let's see. Minus 2x squared plus 7xy minus 6y squared equals 0. Okay, so you're okay with this being minus 4x plus 7y plus 7x, yeah, minus 12y dy dx equals 0. So then you get dy dx equals 4x minus 7y over 7x minus 12y. So then you get dx dy equals 7x minus 12y over 4x minus 7y.
Did you read the question?
Yes, I flipped them, yeah.
Good. So then x is 2 and y is 1. So x is 2, y is 1. X is 2, y is 1. So what's that? 2.
Okay, can you go back to the okay. Yeah. I know what I did. So I can take like the 7y plus 7x to be the coefficient of dy dx. That's what I did. And I added it to the minus 12y.
You added 7y and 12y?
Yes.
I should throw you out of my classroom for doing such a thing. Yeah, you can't add this and this because this is with this.
Yeah, I know, but I assume that 7y plus 7x is the coefficient of dy dx.
Oh. No. Yes, not this. Yeah. Okay, so that's that one then. That was 3G from the implicit lesson. Right. What's next?
Question 11.
In this
That,
lesson? Faisal, what? Alright. Find the equation of the normal. Oh, sorry, do you need to write that down, Yusuf? No? Okay. Right. Find the equation of the normal to the curve x squared minus 2x plus y squared minus 2y minus 7 equals 0. Yeah? At x equals 1. Okay, so what do we need to do first? Derivative, yeah. So we get 2x minus 2 plus 2y dy dx minus 2 dy dx equals 0. So dy dx equals 2 minus 2x all over 2y minus 2. So that's 1 minus x over y minus 2. And you might be thinking, okay, I'm nearly finished. Is this okay, Wong? Did you see a mistake? Huh? Oh my goodness, what did I do that for? Thank you. That was it? Yeah. Now you might be thinking, oh great, so I'm nearly finished. I just put my x and y in here and I just have an x. So, how can I get the y?
Sub in the first one.
Yeah, sub it into the first one. So you get 1 minus 2 plus y squared minus 2y minus 7 equals 0. Y squared minus 2y. Minus 9 plus 1 is minus 8. So you get two answers for y, 4 and 2. Y minus 4, y plus 2. So y equals minus 2 or 4. But you only take this answer, because in the question I said y is between 0 and 5. So we reject that and we put this one in. So that would be 1 minus 1. Oh, it didn't actually matter about the y at all. Didn't matter at all. So we get 4 minus 1, so that's 0. So that tangent, whatever the curve is, I'll just draw a circle for the curve. That tangent, for example, has a slope of 0 at the point, what was the point? 1, 4. Now I lied again, we do need to know the y, but not to calculate. Let me draw it again. This is 1, 4, and the tangent is 0 sloped, so it means it's a horizontal line. But I said in the question I want the vertical, well, not the vertical, the normal, which is the vertical here because it's perpendicular. So what is the equation of this line if you think all the way back to week 1, semester 1?
X equals 1.
X equals 1 is the equation of this line, which is perpendicular to that line, which is horizontal. So x equals 1 is the equation of the normal.
We still don't.
I thought we had.
Yeah.
I thought we had to.
I wonder if I did that on purpose or by accident. I did that on purpose.
Yes,
Yes.
of course.
Yes.
Yes.
Totally not an accident. Yes? Yeah.
Can you
Well,
do-
is it about this or another one to do? Because I'll just give Fawang a minute to look at this one.
I thought we have to find the M.
You can't because,
Yeah.
yeah, the line is vertical, so it doesn't have an M, really.
So what can we say in the final answer?
X equals 1.
Let's say that.
Mm-hmm. What's up? Beautiful. I don't judge you. We're all weird in here. It's just different level of weirdness and different We're all weird in different ways, and that makes us special. Yeah. Yeah. All right. What? Huh?
Preach.
Yes. All right. What do we want to see next then? You said you have something. Yeah.
Like the other one, because I did it now again, and I'm not getting the same answer.
This is the last time then, and if I get the right answer, we're not doing any more of these, okay? Right, m of the same one, so 3m then. Three m 4x squared plus 7xy plus 3y squared equals 0. Minus 3 and 4. Yeah? Okay, so that is 8x plus 7y plus 7x dy dx. 6y dy dx equals 0. So then dy dx equals minus 8x minus 7y over 7x plus 6y, which equals 24 minus 28 over minus 21 plus 24, which is minus 4 over 3. Minus 4 over 3.
Yeah, but why can't I write...
Wait!
Yeah, you
And
can flip
yeah,
it,
yeah.
yes. But why can't I write like 7x plus 7y?
Oh, not this again. You just said you know that these don't go together.
I know, but why didn't you write the 7y beside the dy over dx? Not
The 7y over... wait, what?
like swap the positions of the 7y and 7x.
Why?
Yeah, why?
Like
The
the
formula.
product rule just says you differentiate one and leave the other one as it
Yeah.
is. And then what
So we're
if I
looking at the-
differentiate y first?
Fine, fine. So if you differentiate y first,
Yeah.
you would end up with 7x dy dx, and then you differentiate the 7x next.
Yeah.
This is awkward for you right now, isn't it? Alright. Are you good now with this? Are you sure? Okay. That's 3m then. What else do we want to see?
And you listen.
No, because I'm not convinced
Oh, the product
that
rule.
everything has been mastered up until this point.
The product rule.
The product rule, okay.
At the
Which one?
the question 2G.
Now, yeah, I haven't, my answers at the back are desperately needing simplification, but we'll see. Oh yeah, 2G. 2G. Log x squared log x, yeah.
Something like no 1 over x cubed.
No.
No, got it.
Log x, log x, log x is the question, because it's log x squared by log x. So the derivative would be 1 over x, log x, plus log x, 1 over x, log x, plus 1 over x, log x, log x. So that's 3 over x, log x squared is the answer. You have the same answer as me.
Why?
No, that square is on the log x, not the x.
Why does it get squared?
Log x by log x.
Three
So,
times.
But
no, 3 times is 3 over x.
A squared
Yes, yes,
is
yes.
A by
Yes.
A. Yeah. So A by A is A squared.
Squared.
Yes. Okay.
but I thought the answer is different.
I might have written the answer just in a different form. Look, when I tell you something about that worksheet, okay, I didn't make all the questions on that worksheet. What I did was I made a computer program to generate the questions and the answers. It's just I didn't write the program to simplify the answer. So that's why some of the answers look weird. because you know, programming. Yes? Yes? Any other questions?
The domain and range.
Yes. Yes.
Question 2R.
Domain and range. Is this the one I think it is? Let me hope so, I hope so.
It's okay.
2R.
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 Yeah.
No, it's not the one I was hoping for. Okay. What am I asking for here? The range.
Yeah.
Yeah. Does this have factors? Well.
Yes, I think. No.
It doesn't matter anyways. So, remember the steps. You say y equals this. Yes? Then you cross multiply. And you get this. And then you simplify. And this is a quadratic. And we require the quadratic to have solutions. So when will the quadratic have solutions?
When y.
No? Well, no. Well, y should not be 0 for sure.
Yeah.
So you don't want a 0 y, because otherwise you don't actually have an equation where you can find the x. So that's one thing automatically. But something else too? Something to do with something you did in semester 1 when you studied quadratics? It's Greek. It's triangular. No, not that Greek. A different Greek. Greek letter. Triangular shape. Oh, dude. You want the discriminant to be positive. Then it has solutions.
Yeah.
And we all know this. Don't we? Yeah. So, I need the discriminant to be positive and y not to be 0. So I have b.
But if equals 0 is okay.
Yes, because it has one solution. Yeah. So b squared minus 4ac. Yusuf, can you square 42, please?
1764.
And 425 times 4, please. That's going to be 1700.
Yes.
And then finally minus plus 4y bigger than or equal to 0. That's just going to be 64, isn't it? Nice, because now I can divide by 4. And this can be factorized like this, right?
Where did the y go?
What y?
So, like you divide by 4, right?
Correct.
And then he took y as a common factor.
No, like the first step to the second.
Here?
Yeah, there's a variable missing, right?
Is there?
He
Y
divided-
square minus one.
This minus this is this. Yeah. Okay, so here, this is the y actually. You're looking for above or below? Above or below? Wakey wakey.
Above.
Above. So that's here and here. So you need y to be less than or equal to minus 1 over 16, or y to be bigger than or equal to 0. However, we said earlier y is not 0. So bigger than 0. So the answer is the range is everything from minus infinity to minus 1 over 16, including 1 over 16, or from 0, not including 0, to infinity. How far into this did you get, Yusuf?
I didn't even do the first step because I did it wrong. I just took the x squared minus 4 2x and I differentiated it.
Differentiated? Man, you were way off. Way off. Alright, before continuing, this topic here, I'm sure you haven't done this in high school before. What I just did there. Or maybe I'm wrong. I'm right. You did this in high school? You remember doing this? Are you sure? I don't believe you. But anyways, you did this in high
I
school?
didn't do it in I did the S's and the L's.
Okay. I guess I could believe you, but I just can't. I've been lied to too many times before. So before going on to the next lesson, I want you all to try one of these, and I really, really want you to try the super hard one, which is K. And then I feel like if you can get K done, then you've mastered how to find the range of a function. This is an exam question. The good news is, the ones that I'm giving you here, K and OR, are a bit harder than what you get in the exam. So if you can do these, you can certainly do what you get in the exam. Okay? So try your best now to do K, and then I'll do it in a minute. Right, so please don't think I haven't forgotten the sweet message you left for me yesterday. Don't break my heart. Don't play with me like this. Please be a good student and do this.
Discriminant is b squared minus 4ac.
finish. Could be right. I'll have to do it. Right, this is the whole answer? Just this? No, too short. That's a turbo-sized answer. You need at least a Stephen-sized answer. That's way too small.
Could be.
Could be, but maybe not. You got an answer, Lee?
Can I see the answer?
Okay, you want to check the answer? Were you right?
Nearly.
Really? Alright, let's have a look. What was the function here? X squared?
-5.
Oh, okay, sorry. You nearly have it? Super. Yeah? Great. Yeah? Okay. So, what was it? X squared?
Minus 4x minus 5 over x squared minus 4x plus 3.
Right, so step 1, make it equal to y. I would be very sad if you didn't get this step. Step 2, try to make it an equation equal to 0. So, by cross multiplying, you have yx squared minus 4yx plus 3y equals x squared minus 4x minus 5. Taking everything to the left, we have y minus 1x squared plus 4 minus 4y, or minus 4y plus 4, if that's what you wrote, that's fine. Plus 3y plus 5 equal to 0. Now, did you get that, Yusuf? Yeah. Before we proceed, is there anything we can say about the y? Well, if y is 1, this is gone, which is not necessarily a problem, but it is a problem here, because if y is 1, this is also gone. So we can immediately say that y is not 1. So the range is immediately missing 1. So 1 we can't use. If this quadratic is supposed to have solutions, then its discriminant needs to be bigger than 0. So we have b squared minus 4ac needs to be bigger than or equal to 0. That's 16 minus 32y plus 16y squared. I hope I got that. Minus 4 times 3y squared plus 2y minus 5. And I multiply out those two. So, altogether now, I get 16 minus 12 is 4y squared, minus 32y minus 8y is minus 40y, 16 plus 20 is 36. I again can divide everything by 4. I get 2 answers. Now, I want above. My 2 answers are 1 and 9. And I want above. But I can't have 1. So y needs to be less than 1, y needs to be bigger than or equal to 9. So I finish off by saying the range is everything from minus infinity to 1 or 9 to infinity. Difficult question. Did you get this, Yusuf?
Why can't be
Yeah.
1?
But you made a mistake.
Yeah, I'm sorry.
Those signs. Why can't y be 1? Because here, if y is 1, then you get 5 equals 0. This is the most difficult question, I think, on the worksheet, which is why I wanted to do it. In the exam, they usually stick to linear over linear, which is good for you. So in the exam, they're more like question D or question L. This would be a typical exam style question, L. And F. F is another one they like for the exam. F and L would be the common ones here.
Go back to
The answer?
the discriminant is supposed to be greater
Or equal to 0.
or equal to 0.
Yeah.
Does that have any relevance to our final answer on the range?
No.
Well, it's only insofar as we use this as a starting point to get this. But I don't need to be looking at this to get anything here. I just use this to form this equation. This part here is A, B, and C.
And it's always, the discriminant has to be greater than 0 or 2.
Say what now? You're mixing up words here, or mixing up ideas. When you're dealing with quadratics, the discriminant needs to be bigger than or equal to 0 if it's to have solutions. If the discriminant is less than 0, then the quadratic doesn't have any solutions. So you probably remember it. Positive means 2 solutions, 0 means 1 solution, negative means no solutions. And we demand to have at least a solution in this method. This method works because you find values of y that makes your equation have a solution. This is the technique for finding the range. There are other techniques though, but they're quite difficult compared to this. So if you were really, really good at drawing your graphs, you could draw the graph for this and you would discover that your graph would go down to 1, but not quite reach 1. And no, I think I have this wrong. There's 1 and there's 9. Yeah, so your graph would probably look something, I don't know, something weird, like it can go up to 1 or it can go down to 9, but 1 to 9 is missing. So this is why you have this here. You know what, I think it would be great actually to have a look at this graph, because I usually do that in class. So let's have a look at this graph. There are other ways to do it as well, but this is the only method I know of that works for every question and is about the same difficulty for every question. The graph is kind of sometimes easy, sometimes hard. Like for example with a quadratic, the range is from the minimum up. So if you had a quadratic, if you found the minimum, then the range would be everything from that value up. So for quadratics you could use the graph. For cubics you could use the graph. What's the range of a cubic?
Infinity. Negative to positive.
Yeah, it's everything. But for something like this, you know, what the heck type of graph does that make? A quadratic over a quadratic?
Linear.
Yeah? Or maybe quadratic over quadratic makes linear? Yeah?
That would make more sense.
That would. But both are wrong. So let's have a look at this graph to see. Now what's interesting is, see how in the range we include 9, but don't include 1. So there must be something we can see on the graph that lets us have the 9 on the y-axis, but then doesn't let us have the 1 on the y-axis. So we'll have to see what that looks like. And the graph should go down to minus infinity, and it should go up to plus infinity. You can see that in the answer. Yeah. Okay. So what is on the top? Did you say use of x squared?
Minus 4x minus y.
Yep.
And x squared minus 4x plus 3.
Okay. Let me zoom out before I draw it. Right. Ready? Kaboom.
Not even close, Mr. Stephen.
No, it's close.
So you are drawing?
Oh no, not even close to my drawing. But I don't know how to draw this, so that's why I said the graph is a hard way to do this. Now we can see why we include 9, because the 9 we can achieve because it's the bottom of this sort of quadratic shape here. Let me expand it a bit. No, wrong way. So this is why we can have the 9, because it's the bottom of this quadratic shape. But why can we not have the 1? Because the 1 is never quite hits it. This is continually trying to approach the 1.
Why? 1 is an asymptote, 9 is a tangent.
Yeah, that's it. Yeah, 9 is a tangent here, because it's like a quadratic. 1 is an asymptote here. Yeah? So, that's a very difficult graph to draw. Very difficult graph to draw. But it matches up perfectly with our answer, which is satisfying. Yeah. Okay. This graph is not on the exam, but I would like you to add this graph to your answer. I think would be nice. So can you just roughly sketch this beside your answer, please?
Is this how a graph of a square over square would look like?
Yeah. So I think, Faisal, what's happening is when the x is around about near 2, when it's between 1 and 3, the denominator must roughly have the value of 1 or nearly 1. So like for example, I wouldn't be surprised if when you put x equals to 2 or 1 or 3, the denominator doesn't change much, you know what I mean? That it must be reasonably constant. So that means the quadratic on the top is the thing that changes more significantly, which makes it the quadratic shape here.
Yeah.
Then when you have 1 and 3, they must be the roots of the denominator because they break there down to minus infinity. So 1 and 3 must be the roots of the denominator. And then what happens when we make the x really large and really small?
1 and 3 are the roots of the denominator.
Yeah. When the x is really positive or negative, the graph flattens off because the denominator must get so big. And the denominator on the bottom must be getting bigger than the numerator, so that the denominator is winning out and making the fraction smaller. So that's why it's leveling off there. You could, if you examine the quadratic over the quadratic in this way, you could try and make this graph yourself, you know. If, for example, the numerator got bigger than the denominator faster when x got large, then the graph wouldn't level off at the ends. What would happen?
If the what?
If the numerator grew faster than the denominator.
Yeah. If they won't go, they'll go up.
Yeah.
Or down.
Yeah. Yeah. But I think here the numerator and denominator actually grow at about the same rate because it's leveling off. Which they do actually, because if you think about it here, they both had x squareds in it.
And 4x.
And 4x. So it's almost like...
This won't make a big difference.
Yeah. Anyways, please add the graph to your answer.
Can you zoom out?
Zoom out, sure.
the root of the numerator is the x coordinates where they cross the x-axis,
Yes.
and the roots of the denominator.
Or where they break vertically.
Yes. Okay, now it makes sense. Nice. I like it.
See? I wanted to do it. I have a feeling that if you differentiated this and made it equal to 0 to find the turning point, you probably will only get one answer, which should be this one here, which will be the same as the turning point of the numerator. I think. I don't know. Okay, did you draw that? Yep. Alright. What lesson are we on now?
Wait.
More questions?
Yeah.
Ah, no. That's enough of a tutorial. What? What lesson?
Chain rule.
Next week. I can't give more time to this. We already had a full lesson on this.
But just past question.
Next week.
Next week we will forget.
Don't forget.
And next week we will have no time to do.
Yes, we will. I promise you. We'll do this one first next week.
And then the other question will.
We can go faster if we don't let the stupid students into the class for next week. Yes? You just tell me who we don't let in. Huh? Or maybe we don't let the talky students in. You know the talky students? See the talky student there? He's alright, he doesn't talk too much, but he talks a bit. Yeah.
But I also.
You're a bit of a talky student as well. Yeah. Yeah. You need to be more like Lee. He never talks in class. The only time he talks is when I made a mistake. When he has something really important to say. Yeah. Okay.